to people. What's that process?
Well, routine radiation releases from every stage of the uranium fuel chain take place, but at the reactors especially. Like I said, the uranium fuel becomes 1 million times more radioactive when it passes through a reactor for several years. There are leaks in these fuel rods, so the primary coolant water becomes contaminated. Some of it gets filtered out, but there are leaks in the system. And so the Nuclear Regulatory Commission, again, grants permits to utilities to discharge radioactivity on a routine basis into the water, because all of the nuclear power plants are located on water for cooling purposes. Well, they're also taking advantage of their location on water to dump radioactivity into the river, the lake, the ocean, where they're located. And another pathway for routine radiation releases is into the air. They have atmospheric discharges. And this is somewhat different and more shocking, in a sense, than even the leaks that are going on at these old plants like Vermont Yankee. They're having very serious and large-scale leaks of tritium, which is radioactive hydrogen, into the groundwater and then into the Connecticut River. Well, where was that tritium going to when it leaked? It was being discharged on a routine basis with permission from the U.S. federal government. So yes, it does become more concentrated when it leaks into groundwater, but the whole philosophy of the Nuclear Regulatory Commission and the nuclear power industry is dilution is the solution to pollution. They were going to dump it directly into the air and into the Connecticut River in the first place. And people living downstream are being exposed to these radiation doses. And the National Academy of Sciences, for decades now, has repeated their finding that any exposure to radioactivity carries a health risk, no matter how low the exposure, and that the risks are cumulative, that the risks go up the more you're exposed.
What about the so-called success of the French nuclear program?
Well, there's a lot of myths surrounding the French nuclear program. The U.S. nuclear establishment loves to point to France, and they say the French have figured everything out. They get 80% of their electricity from nuclear power. But what are some of these myths? One of the myths, and again, the chairman of the U.S. Nuclear Regulatory Commission has said himself that the idea, the notion that the French have solved their radioactive waste problem is one of the best myths out there. That's a quote. He said that. And it is a myth, actually, because what the French do is they reprocess high-level radioactive waste. They extract plutonium, supposedly to reuse as reactor fuel. That program has largely fallen apart at huge expense to French ratepayers and taxpayers. They're sitting on a mountain of separated plutonium in France, which is weapons usable. They have to guard that plutonium supply 24/7, very carefully, because just a small quantity of that plutonium could be used for a nuclear weapon. So they have to secure the separated plutonium. In addition, they discharge a lot of radioactivity into the air and into the ocean. They have an underwater pipeline into the English Channel, and they dump 100 million gallons of radioactively contaminated liquids every year into the ocean. It's traveled as far as the Canadian Arctic, and it's contaminated the seafood supply. So there's a dozen European countries outraged by this practice. And the gaseous releases from the French reprocessing facility are quite startling as well, especially gases like krypton, radioactive krypton. In a single year's operations at the Le Hague reprocessing facility in France, more radioactive krypton is released than all of the atomic weapons blasts from the 1940s through the 1960s. And another radioactive gas released from reprocessing is carbon-14, radioactive carbon-14, which has a 5,000-year half-life. So you multiply the half-life by 10 for the hazardous persistence, 50,000 years of hazard. So nuclear power is pointed to as a solution to carbon dioxide releases. Well, the nuclear fuel chain releases carbon, and it happens to be radioactive. Radioactive carbon-14, one of the most hazardous of the radioactive isotopes, because it will integrate into living tissues, including in humans, where it will deliver its radiation dose. And the same can be said of tritium, this radioactive form of hydrogen, which can integrate down to the most intimate levels in the human biology, right down to the DNA molecule. And that's why it can initiate cancer, genetic damage, birth defects.
What about the issue of global warming and the claim that nuclear power doesn't contribute to global warming, doesn't emit greenhouse gases?
Well, the industry would like people to think that there are zero greenhouse gas emissions from the nuclear power industry. It's not true. There are greenhouse gas emissions, especially the front end of the nuclear fuel chain is very energy intensive. Most of that energy is fossil fuels. From the mining and milling to the processing, and then especially the enrichment of uranium. 2 uranium enrichment facilities in the United States operated from the 1950s really up until the present day. One of them is still operating, using 2 coal-fired power plants at each of these uranium facilities. Every watt of electricity from this dirty coal that was being burned was being used to enrich uranium. It was 1% of the electricity usage in the United States for decades on end. And in addition, it was a huge releaser of ozone layer destroying chlorofluorocarbons. So there are these greenhouse gas emissions, there's ozone destroying chemicals released. But some of the other reasons that nuclear cannot solve the climate crisis is the astronomical expense of nuclear power. Reducing greenhouse gases with energy efficiency is 10 times more cost effective than new atomic reactors in the United States. Renewable sources of electricity, like wind power, are very cost competitive with nuclear at this point. Wind is coming down dramatically in price, and this is reflected by the major expansion in wind power. Just last year in the United States, 7,000 megawatts of new wind was installed. How much nuclear was installed? 0% was installed. And you can go back for 30 years and have very little nuclear power coming online, while wind is growing by leaps and bounds. And even solar technology is coming down dramatically in price. Probably in a few years' time, solar centralized facilities will be cost competitive with nuclear. And this is very remarkable because nuclear power, just like fossil fuels, has enjoyed the lion's share of public support for decades on end, whereas wind and solar have gotten the crumbs, if that. So despite the disparity in subsidies, renewables are competitive and actually out-competing nuclear power.
Sometimes Patrick Moore, he was involved years ago with Greenpeace, is pointed to as an example of some environmentalists now embracing nuclear power. How do you respond to that?
Well, Patrick Moore himself has gotten a lot of media attention, unfortunately. The question is never asked, or very rarely asked, why are you doing this? And he will answer the question if asked, and it's because he's being paid by the Nuclear Energy Institute. His organization is a front group for the Nuclear Energy Institute, and he will readily admit that that's the case. So he's being paid very likely a handsome salary for what he's doing. And in fact, he has done very similar work, if you can call it that, for other polluting industries, from genetically modified organisms to clear-cut timber practices. You name it, pesticides, he's willing to sell out for it. And he uses his past Greenpeace affiliation as his selling point. The truth is that if you look at the hundreds and even thousands of environmental organizations from the grassroots level to the national level, international level, in the world and in the United States, the vast majority, almost to a single group, is very skeptical, if not outright opposed to nuclear power. So it's a myth that environmentalists are embracing nuclear power. Quite the opposite.
On the 1986 Chernobyl accident, there are some who say that, well, that was an old Soviet design, and that's the problem, not nuclear power.
Well, the United States has had some problems of its own. 3 Mile Island, of course, in 1979 was a 50% meltdown with serious radioactivity releases. We've had some close calls in recent years. Fortunately, there was not a meltdown or a large-scale radioactivity release, but we came very close. Davis-Besse, near Toledo, Ohio, a massive corrosion hole in the lid of the reactor. 7 inches of steel were eaten away by acid. All that was left was 3/16 of an inch